canals and navigations are human-made channels for water conveyance, or to service water transport vehicles. In the vernacular, both are referred to as canals, and in most cases, the engineered works will have series of dams and locks creating areas of low-speed current flow referred to as slack water levels, often just called levels. The main difference between them is that a navigation parallels a river and shares part of its waters, its drainage basin, and leverages its resources by building dams and locks to increase and lengthen its long stretches of deep enough slack water levels while staying in its valley. In contrast, a canal cuts across a drainage divide atop a ridge, generally requiring an external water source above the highest elevation. Many canals have been built at elevations towering over valleys and others waterways crossing far below. Cities need a lot of fresh water, and many canals with sources of water at a higher level can deliver water to a destination where there is lack of water. The Roman Empire's aqueducts were such water supply canals. Types of artificial waterways. A navigation is a series of channels that run roughly parallel to the valley and stream bed of an unimproved river. A navigation always shares the drainage basin of the river. A vessel uses the calm parts of the river itself as well as improvements traversing the same changes in height. A true canal is a channel that cuts across a drainage divide, making a navigable channel connecting two different drainage basins. Most commercially important canals of the first half of the 19th century were a little of each, using rivers in long stretches, and divide-crossing canals in others. This is true for many canals still in use. Structures used in artificial waterways. Both navigations and canals use engineered structures to improve navigation, weirs and dams to raise river water levels to usable depths, looping descents to create a longer and gentler channel around a stretch of rapids or falls, locks to allow ships and barges to descend. Since they cut across drainage divides, canals are more difficult to construct and often need additional improvements, like viaducts and aqueducts to bridge waters over streams and roads, and ways to keep water in the channel. Types of canals. There are two broad types of canal: waterways, canals, and navigations used for carrying vessels transporting goods and people. These can be subdivided into two kinds. Those connecting existing lakes, rivers, other canals or seas and oceans. Those connected in a city network, such as the Canal Grande and others of Venice, Italy, the Gracht of Amsterdam, and the waterways of Bangkok. Aqueducts. Water supply canals that are used for the conveyance and delivery of potable water for human consumption, municipal uses, hydropower canals and agriculture irrigation. Importance. There is a silly little nursery rhyme which, given a little thought, leads to a train of thought illustrating why water transportation of heavy or bulk loads was so very important when animal power predominated over machinery, or why sea transport and ship canals are still very important today. Speaking of carrying milk, a pint is a pound the world round, school children were taught. Hence 8 pints to the gallon means a gallon of water. Milk, as similar liquids, weighs about 8 pounds. The friction given by water against a hull is trivial compared to moving that same load on land, because pressure pushes equally in all directions, and the water displaced creates such a pressure. Water lifts in exact proportion relative to the displaced volume of water, so displacing a gallon of water down results in the pressure equal to its weight pushing back. In fact, pressure increases with depth, so the deeper the hull, the more the incremental amounts of buoyancy the displaced water creates pushing back up. Boats, barges, and ships are designed to be strong enough to carry vast weights while staying materially light using shell-like construction. Historically, canals were of immense importance to commerce and the development, growth and vitality of a civilization. In 1855, the Lehigh Canal carried over 1.2 million tons of clean-burning anthracite coal. By the 1930s, the company which built and operated it over century pulled the plug. The few canals still in operation in our modern age are a mere remnant, at best a tithe, of the numbers that once fueled and enabled economic growth. Indeed, were practically a prerequisite to further urbanization and industrialization, for the movement of bulk raw materials such as coal and ores, are difficult and marginally affordable without water transport. Such raw materials fueled the industrial developments and new metallurgy, resulting of the spiral of increasing mechanization during 17th-20th century, leading to new research disciplines, new industries and economies of scale, raising the standard of living for any industrialized society. The surviving canals, including most ship canals, today primarily service mostly bulk cargo and large ship transportation industries, whereas the once critical smaller inland waterways conceived and engineered as boat and barge canals have largely been supplanted and filled in, abandoned and left to deteriorate, or kept in service and staffed by state employees, where dams and locks are maintained for flood control or pleasure boating. The replacement was gradual, almost insidious, save it had no guiding intelligence plotting against them, and was at least initially all but unnoticeable, beginning first in the United States in the mid-1850s, where canal shipping was first augmented by, then began being replaced by using much faster, less geographically constrained and limited, and generally cheaper to maintain railways. By the early 1880s, canals which had little ability to economically compete with rail transport were off the map. In the next couple of decades, coal was increasingly diminished as the heating fuel of choice by oil and growth of coal shipments leveled off. Later, after World War I, when motor trucks came into their own, the last small U.S. barge canals saw a steady decline in cargo ton miles alongside many railways. The flexibility and steep slope climbing capability of lorries taking over cargo hauling increasingly as road networks were improved, and which also had the freedom to make deliveries well away from rail-lined road beds or ditches in the dirt which couldn't operate in the winter. Construction. Canals are built in one of three ways, or a combination of the three, depending on available water and available path. Human-made streams. A canal can be created where no stream presently exists. Either the body of the canal is dug, or the sides of the canal are created by making dikes, the levees by piling dirt, stone, concrete, or other building materials. The water for the canal must be provided from an external source, like streams or reservoirs. Where the new waterway must change elevation, engineering works like locks, lifts or elevators are constructed to raise and lower vessels. Examples include canals that connect valleys over a higher body of land, like Canal du Midi, Canal de Bras and the Panama Canal. A canal can be constructed by dredging a channel in the bottom of an existing lake. When the channel is complete, the lake is drained and the channel becomes a new canal, serving both drainage of the surrounding polder and preventing transport there. Examples include the Lage Vart. One can also build two parallel dikes in an existing lake, forming the new canal in between, and then drain the remaining parts of the lake. The eastern and central parts of the North Sea Canal were constructed in this way. In both cases, pumping stations are required to keep the lands surrounding the canal dry, either pumping water from the canal into surrounding waters, or pumping it from the land into the canal. Canalization and navigations. A stream can be canalized to make its navigable path more predictable and easier to maneuver. Canalization modifies the stream to carry traffic more safely by controlling the flow of the stream by dredging, damming and modifying its path. This frequently includes the incorporation of locks and spillways that make the river a navigation. Examples include the Lehigh Canal in northeastern Pennsylvania's coal region, Basin Canal de Mines de Fer de la Moselle, and Ain River. Riparian zone restoration may be required. Lateral canals. When a stream is too difficult to modify with canalization, a second stream can be created next to or at least near the existing stream. This is called a lateral canal, and may meander in a large horseshoe bend, a series of curves some distance from the source water's stream bed, lengthening the effective length in order to lower the ratio of rise over run. The existing stream usually acts as the water source, and the landscape around its banks provide a path for the new body. Examples include the Chesapeake and Ohio Canal, Canal Latte-Loire-Garonne Lateral Canal, and Juliana Canal. Smaller transportation canals can carry barges and narrow boats, while ship canals allow seagoing ships to travel to an inland port, or from one sea or ocean to another. Features. At the simplest, canals consist of a trench filled with water. Depending on the stratum the canal passes through, it may be necessary to line the cut with some form of watertight material such as clay or concrete. When this is done with clay, it is known as pudding. Canals need to be level, and while smaller irregularities in the lie of the land can be dealt with through cuttings and embankments. For larger deviations, other approaches have been adopted. The most common is the pond lock, which consists of a chamber within which the water level can be raised or lowered, connecting either two pieces of canal at a different level of the canal with the river or the sea. When there is a hill to be climbed, flights of many locks in short succession may be used. Prior to the development of the pound lock in 984 AD in China by Chai Weiyou, and later in Europe in the 15th century, either flash locks consisting of a single gate were used, or ramps, sometimes equipped with rollers, were used to change the level. Flash locks were only practical where there was plenty of water available. Locks use a lot of water, so builders have adopted other approaches for situations where little water is available. These include boat lifts, such as the Falkirk wheel, which use a caisson of water in which boats float while being moved between two levels, and inclined planes where a caisson is hauled up a steep railway to cross a stream, road, or valley. The valley can be spanned by a navigable aqueduct. A famous example in Wales is the Pont Cyswllt aqueduct across the valley of the River Dee. Another option for dealing with hills is to tunnel through them. An example of this approach is the Harecastle Tunnel on the Trent and Mersey Canal. Tunnels are only practical for smaller canals. Some canals attempted to keep changes in level down to a minimum. These canals, known as contour canals, would take longer, winding routes, along which the land was a uniform altitude. Other, generally later, canals took more direct routes, requiring the use of various methods to deal with the change in level. Canals have various features to tackle the problem of water supply. In cases like the Suez Canal, the canal is simply open to the sea. Where the canal is not at sea level, a number of approaches have been adopted. Taking water from existing rivers or springs was an option in some cases, sometimes supplemented by other methods to deal with seasonal variations in flow. Where such sources were unavailable, reservoirs, either separate from the canal or built into its course, and back pumping were used to provide the required water. In other cases, water pumped from mines was used to feed the canal. In certain cases, extensive feeder canals were built to bring water from sources located far from the canal, where larger amounts of goods are loaded or unloaded, such as at the end of a canal. A canal basin may be built. This would normally be a section of water wider than the general canal. In some cases, the canal basins contain wharfs and cranes to assist with movement of goods. When a section of the canal needs to be sealed off so it can be drained for maintenance, stop planks are frequently used. These consist of planks of wood placed across the canal to form a dam. They are generally placed in pre-existing grooves in the canal bank. On more modern canals, guard locks or gates were sometimes placed to allow a section of the canal to be quickly closed off, either for maintenance or to prevent a major loss of water due to a canal breach.